All right, here's number 8. Again, we're still dealing with linear systems and we have word problems. So let's try to pull out the information we need, then solve the system and verify and kind of figure out what all the answers mean. All right, so Tatsukin, I think that's how you say that name, school is selling tickets to a play. On the first day of ticket sales, the school sold 4 adult tickets and 10 child tickets for a total of $144. Oh, did I see the word total? Oh, okay. The school took in $185. Again, that's a fancy way of saying, oh, we made a total amount of $185. On the second day, by selling 5 adult tickets and 13 child tickets. Find the price of an adult ticket and find the price of a student ticket. All right, so I have the two totals highlighted there, and that's the most important thing we need to find because it gives us a lot of other helping information that we can locate later. So, again, the first thing that goes into my right column are totals. So I highlighted $144 and $185. So we have to be able to distinguish what these two different dollar amounts mean. So they're the same units, so I need to distinguish what they mean. Well, it looks like I made $144 on the first day, so first, and I made $185 on the second day. So those are the difference between the two. I made $144 on the first day and $185 on the second day. Now, what was I selling to get that money? Is a good question. I was selling, it appears to be 4 adult tickets. So adult and then child. Okay, so those are our two different categories there. Okay, so now let's fill in our table. And so how many adult tickets did I sell on the first day? So that's what's going to go there. Adult tickets on the first day, I sold 4. And then how many child tickets on the first day? I sold 10. And what's missing are my variables. I'll put A for adult and C for child. All right, how many adult tickets did I sell on the second day? Looks like I sold 5 adult tickets on the second day and 13 children's tickets on the second day. So I put A and C. All right, we filled in the table. Fantastic. Let's go ahead and write our system down below. So 4A plus 10C equals 144. 5A plus 13C equals 185. All right, so now we need to figure out how we're going to eliminate. Again, that's usually the best method to use in these kind of problems. If I try to eliminate C, there's really no easy way to do it. I just have to multiply the top one by 13, the bottom one by 10. But that's not fun. So let's try A. So the least common multiple for 4 and 5 is 20. So I want to make the numbers in front of A, or the coefficients, to be the same number. Again, I want them to be the same number, same variable, but I need them to be inverses, meaning one of them has to be positive, the other one has to be negative. So I know I want to make them both 20, so let's multiply the top one by 5, the bottom one by 4, but I have to make one of them negative. So you know what? I'm going to make the top one negative. Why not? So if I multiply the top equation by negative 5, I'm going to get negative 20A minus, because negative times a positive is a negative, is negative 50C equals 144 times 5. I don't know that off the top of my head, so we have to do some margin math here. 4 times 5 is 20, carry the 2. 4 times 5 is 20, plus 2 is 22, carry the 2. 5 times 1 is 5, plus 2 is 7. So 720. But of course it's negative 720. All right, bottom equation, we distribute a 4. We would get positive 20A. Plus 13 times 4 is going to give me 52C. And then 185 times 4, I don't know what that is. Here we go. 185 times 4. 20, carry the 2. 32, 34, carry the 3. 4 times 1 is 4, plus 3 is 7, so 740. All right, and now I do have inverses, negative 20 and positive 20A. So let's add them together. We get 0A. Plus negative 50, or negative 50 plus 52 is 2C. And then negative 720 plus 740 is 20. All right, now we got to get 0a eliminated. And now we just have 2c. Divide by 2. And c equals 10. All right, but now I'm not done. I got to find a, or the adult ticket. So let's plug that in. You know what? I'm feeling like, let's go right here. Why not? You could plug it into any equation, but that one looks good for me. So we have 4a plus 10 times 10 equals 144. All right, we know that 10 times 10 is 100. And in order to get 4a by itself, we have to combine like terms and move the 100 over by subtracting. So 4a equals 144 minus 100 is 44. And then, in order to get a by itself, we divide by 4. And a equals 11. All right, but again, I'm not quite done because I need to decipher what my variables mean. So, let's figure out a first. So a is 11. What does a represent? Well, a is adults. So, but is it adult tickets, adult money? What are we talking about? What about 11? So, again, the question is find the price of an adult ticket and the price of a child's ticket. So that would mean $11. So it's $11 per adult ticket. And then C is 10, so that means $10 per child ticket. So the thing you just need to be aware of is at the end, when you have to write down what the variables mean, go back to the problem and find the question. So it says find the price. So we're obviously talking about money. Another big clue that you can use is look at the totals. The totals are in dollars, so it should the final answer should also be a dollar amount or a dollar answer. So there's a good hint there. All right, there's number 8.